So now we're going to talk about the solubility chart, which is on page 11. Solubility chart is going to tell us what things will be soluble and what will not. For instance, for the way you read this, okay, this column is all the negative ions. This column is positive ions. And you'll notice right off the bat, anything that is combined with a group 1A or with an ammonium ion is always going to be soluble. Anything that is bonded with nitrate, chlorate, or perchlorate are always going to be soluble. And acetate is almost always soluble. Silver might not precipitate, might have a small precipitate in it. Okay? What does that mean? Well, if you have a compound that starts with Na, it's going to dissolve in water. If you have something, anything from group 1A, which are the elements lithium, sodium, potassium, rubidium, cesium, francium, those are all going to dissolve in water. If you have a compound with that in it, it's going to dissolve. If you have a compound with ammonium in it, it's going to dissolve. If you have nitrate, chlorate, or perchlorate, or acetate, you can just assume it's going to dissolve. But what if it doesn't have those? Okay? Well, the next thing we're going to look at are chlorides, bromides, and iodides. Chlorides, bromides, and iodides are usually soluble. The exception is silver, lead, and mercury. And we refer to these as PMS. P for lead, because it starts, the plumum starts with a P. M for mercury, because the word mercury starts with an M, but not Hg, hydrogyrum. And S, silver starts with an S, not argentium. So we call this PMS, and it stands for lead, mercury, and silver. And everybody can remember that because we all talk about PMS and women with PMS during certain times of the month and so on and so on. So here's the first clue here. If it's PMS, it's probably not going to dissolve unless it was one of these guys up here. Just preview of coming interactions. So silver chloride will precipitate, but sodium chloride will not. Lead chloride will precipitate, but cobalt 2 chloride will not. Iron 2 chloride will not. Iron 3 chloride will not. All right? So, chlorides in general are soluble, with the exception of PMS. Sulfates, same story. Sulfates, I thought I had a highlighter there, are soluble for the most part, except for PMS. Here's our P, silver's here. Here's our S, PMS. And then we throw 3 more exceptions in. The big 3 on the alkaline earth metals, calcium, strontium, and barium. Those guys are exceptions. So chlorine usually going to dissolve except for PMS. Sulfate usually going to dissolve except for PMS, calcium, strontium, and barium. Now, the next row, sulfides, almost always insoluble. Obviously, group 4A and ammonium, they'll dissolve. Group 2A are slightly soluble, but most of the time, if you see sulfide, it's going to dissolve. Sodium sulfide, it's going to not dissolve. It's going to precipitate. Sodium sulfide will dissolve. Calcium sulfide will mostly dissolve, but it's slightly soluble, so you'll have some precipitate. Iron sulfide, not going to see it. It's not going to dissolve. You're going to see a precipitate. Hydroxides, on the other hand, are usually insoluble. Here we have the exception, again, from our big 3 on the alkaline earth metals. Those guys are soluble. Everybody else is insoluble. All right, if you have a phosphate, carbonate, or sulfite, for the most part it's insoluble, unless it's alkaline earth or ammonium. Chromate, insoluble. Ferrocyanide is insoluble with silver and zinc, but everything else is soluble. Oxides, group 1A and 2A are soluble, but looks like a lot of the transition metals are not. Okay? So that's how you read that. Well, why do we care? Well, if we look at this page again, when we put an ionic equation, remember this is the double replacement reaction, what's going to happen, you're going to take the cation and they're going to switch places. So sodium was bonded with hydroxide, and now sodium is bonded with the chlorine and copper is bonded with the hydroxide. So when this happens, we can look at this and see, will these two new compounds dissolve or will they precipitate? Sodium chloride, of course, will dissolve because it's sodium, so we put AQ. Copper 2 hydroxide, however, is going to precipitate. It's going to form a solid. And that's what we're going to use our solubility table for. Here is another one. First, identify what compounds would be aqueous. Magnesium chloride is aqueous. Sodium nitrate is aqueous. But chloride, when it bonds with silver, not sodium, silver nitrate here, silver will precipitate. That's that PMS exception. Magnesium nitrate will stay in solution. Okay, so let's try this one. F2 is fluoride. Fi3, iron 3 iodide. Iodides are usually soluble. They're in the halogen family. So this guy's going to be aqueous. He's actually going to be a gas at room temperature. He's going to be a solid at room temperature. Iron fluoride, even though fluoride's not on your chart, iron 3 fluoride will be soluble because fluoride reacts just like chloride, bromine, and iodide. The next one, iron sulfide, iron 2 sulfide. Is this guy going to dissolve in water? Well, if you look back at your chart, sulfides are insoluble, so he's going to form a precipitate. Hydrochloric acid, acids are always aqueous. Well, when that happens, when they mix, we're going to create sulfuric acid, and then iron 2 chloride. Well, iron 2 chloride should precipitate. So in this case, you're going to have or should not precipitate, should be soluble. You're going to have a solid you add the hydrochloric acid to, and then it's going to be gone. It will react with the hydrochloric acid. The last one on here, calcium hydroxide. Hydroxides are usually insoluble. The exception is the big three on alkaline earth. So this guy should be soluble. Phosphoric acid, of course, soluble. Calcium phosphate will be insoluble. And of course, water is just going to be H2O. This is an example of an acid-base neutralization reaction. All right, we'll be doing some more of this in class.